AS Computer Science, Chapter 2, Communication, Part 2. We start with transmission media. We already studied types of networks. We studied types of network topologies, okay? And we also studied about collision detection and avoidance. This is a problem that may occur when you have a bus topology where all computers transmit on the same shared media. Okay, let us talk now about transmission media. Data would be transmitted between computers in a network using cables or using wireless. So we have two distinct transmission media, either cables or through the air, that is wireless. Okay, we will be comparing between them. Wireless, I mean, for example, Wi-Fi or Bluetooth. This is very popular. Okay. Cables, what do I mean by cables? Okay. You have a cable like this. This is called twisted pair. We have to go into the details. We have a cable like this, and this is called twisted pair. This is a the cable typically used with a star topology. We have to link things together. So, for example, this is a star topology, and you have a switch, and every switch is connected to every computer on a single dedicated transmission line, cable. This cable will be called twisted pair. This is the picture of a twisted pair. There are eight wires inside. Okay, every pair of lines is twisted together to reduce interference between wires. This looks like parallel data transmission, as we have discussed earlier, maybe in the previous year. Okay, so with twisted pair, you have full duplex, send and receive both at the same time. Okay, and you have several wires like this. I think this is the most commonly used transmission media in networks nowadays, because most commonly used topology nowadays is the star topology. We never now use bus topology, a cable like this going through all computers. However, we have to study it so that you can understand benefits and drawbacks. But we call this technology right now obsolete, not used anymore. Maybe somehow used on very limited scale, but commercially not used because of collision. However, if you have a network like this with one cable going through all computers, a bus topology, the cable will be like this, called coaxial cable. As you can see, coaxial cable is just two wires. Okay, and then every computer is transmitting its data on that two wires. It's not very successful right now. Maybe we use this cable right now in connecting your satellite receiver to the antenna or the dish at the top of the building. Okay, so this coaxial cable is now used with televisions rather than with network. However, it used to be used in old days when all computers were connected in a bus topology. Okay, so this is very commonly used now. This is very rarely used now. And this is a very new technology. This is called fiber optic cable. This cable is made of wires of glass. This cable is made of glass that transmits data as light pulses. Definitely much faster, because it transmits data at the speed of light. these two cables, they transmit data as electrical signals. Okay, electrical signals are very fast. However, pulses of light are extremely fast. Okay, in old days, they used to use fiber optic cable to connect between servers and connect between routers and for the infrastructure. They used to use fiber cable to connect between countries. Nowadays, they also use fiber cables to connect internet to your home. And this is called a fiber to the house. This is a very new technology where your internet speed is extremely fast. Okay, so let us compare between those three cable transmission media, because next we will move into wireless transmission media. Okay, so let us study a comparison. A cable is a transmission media using copper or fiber optic. This is copper and this is copper. This is glass fiber optic that transmits data using light pulses. Okay, the option for cables are twisted pair, coaxial, and fiber. This is twisted pair, this is coaxial, and this is fiber. The first two use copper for the transmission media. The last one uses light and material made of glass for transmission media. Let us discuss bandwidth. The bandwidth of fiber optic extremely fast. With bandwidth, I mean transmission speed. Bandwidth refer, the higher the bandwidth, the faster you transmit data. Bandwidth is a measure of the amount of data that can be transmitted per second. Below are some comparison of bandwidth. Okay, so twisted pair bandwidth is low. This twisted pair band. Coaxial is higher. Fiber much higher. The cost of twisted pair is low. Coaxial is higher, and fiber is very expensive. Attenuation at high frequency, which means if you send high data, the data will be lost very soon. You need to put repeaters after maybe 100 meters or so with distance. Okay, so twisted pair is affected by attenuation at high frequency. The fiber is least affected. The fiber is made of glass. Okay, interference. No interference in fiber. Okay, however, with twisted pair, you have interference between wires. Need for repeaters. What is meant by repeaters? We will be saying few minutes later. A repeater is a device that receives a signal, boosts that signal, and retransmits it again. Because with distance, the signal may be lost. So you put repeaters. Okay? Okay, so that was a comparison. Twisted pair, one cable of 4 twisted pairs. This is the twisted pair with different twisting rates to reduce interference. These two lines are twisted together. These two wires are twisted together with different rates. Okay, just to reduce interference. Okay, copper cabling is less expensive and easier to install because it is more flexible. It is easier to make termination using copper cable. The expertise, which means the skills in the use of copper cable, is more extensive, and it has been around many years. Okay, so the skills using twisted pair is already available. However, the fiber, actually now the competition is between twisted pair and fiber, and that coaxial cable is rarely used, so it is out of competition, out of comparison. Okay, so the expertise you have in dealing with twisted pair is much extensive. The skills in dealing with fiber cable is very rare. Not anyone can know how to deal with fiber cables, especially fiber cables may be broken. They may be broken during installation. And once the glass inside is broken, this cable is very expensive. Dealing with it is very, you need to be very careful. Okay? Okay, so this is actually this is a comparison between twisted pair and fiber optic. And coaxial is used extensively with television. It's not used now anymore with networks, especially because it is used with bus network where collisions occur, and this is a very old technology. Okay, fiber optic cable, it is a bundle of glass or plastic threads. So it is not a wire, it is a thread. So I think thread is a very suitable term for what's inside this cable. Okay, to transmit data, fiber optic cable have greater bandwidth. They are very fast. They transmit data at the speed of light. And less signal boosting. You need repeaters less often and can transmit over long distance. They use fiber to connect countries. For example, there is a submarine cable connecting Egypt to France. There is another submarine cable connecting Egypt to China. And these two cables, they carry all of the internet traffic for Egypt. Okay? Fiber optic cable have greater security and more difficult to tap into. You cannot listen to what data is being transmitted, because if you want to tap into a glass, you break it. So you cannot unwittingly listen to what is being transmitted. They are immune to electromagnets. These are affected by electromagnet fields. Okay? They are immune to electromagnets and other effects. They are lighter in weight and consume less power. They take less power. Okay? Because the data is sent in the form of light signal. Okay, advantage of using fiber optic, disadvantage of using fiber optic, definitely compared to twisted pair. Okay, and actually these are answers to questions from past papers. Okay, greater bandwidth and faster transmission speeds are possible. Less interference in the signal. The signal does not degrade as quickly and leads less signal boosting, more secure and more difficult to hack. As you can see, this question is reflecting the discussion we are having here. Disadvantages of fiber optic: initial installation cost is very high. Cable hardware is more expensive to buy per meter. Specialists and trained personnel are needed to install and maintain. Difficult to terminate as the electromagnetics at both ends are very complex. Is more difficult to terminate. What is meant by terminating? Making a connection between the cable and the device. Making a connection between the cable and the device is very delicate and is very complex. Fibers can break when bent. Okay, so as you can see, now I think in the exams they ask quite often about fiber because it's a new technology. It is a technology that will be extensively used in the future. Okay, let us now go to wireless. Okay, now everyone at home is using because you have a network at home. You have a wireless local area network at your home. This is typically created using Wi-Fi. That's why we study wireless transmission. The alternative to cable is wireless transmission. The three options here are radio waves, microwaves, and infrared. The Wi-Fi is something between radio waves and microwave. Infrared is the way the remote control communicates with your television or satellite receiver, for example. Infrared is used in the remote control. Okay, remote controls, you have a LED at the front of it, transmitting pulses of light you cannot see. Why you cannot see? Because it is infrared. Your eyes can only see till the red. Infrared, below the red, you cannot see. Okay? So infrared is used as you, because infrared is a kind of very close to the visible light. It cannot be transmitted through walls. So, for example, you cannot use the remote control with the television in the other room because this is infrared. However, with Wi-Fi, because Wi-Fi is something, we have we have Wi-Fi 2.5 giga, and this is the frequency. Okay, so we have Wi-Fi 2.5 giga, and we also have Wi-Fi 5 giga. These are the wireless frequency. If it is, so we have here radio and microwave and infrared, and it depends upon the frequency of the light wave. You may know about this in physics. We don't have to study that much in details because we are not doing physics. But okay, light has a frequency. Okay, so if it is in that range, we call it radio waves. Okay, an example of this is the old Wi-Fi. Old Wi-Fi transmits data at 2.5 gigahertz. That is something here. New Wi-Fi transmits data at the frequency 5 gigahertz. Okay, and this is microwave. If we'd like to compare, data is transmitted faster in this region. However, penetration through walls is much weaker. Okay, so if you are close to the router and you use microwave, your data is going to be very fast. If you are away from the router, or to be precise, away from the wireless access point, if you are away from the wireless access point and use the microwave, the penetration through the wall is very small. Then the signal will be lost. Then you would rather use the slower one because penetration through walls and signal degradation with distance is not that bad. Okay, so this is a very small comparison between radio waves carry data wirelessly in the form of electromagnetic waves. This is often used as Wi-Fi. Carries data in the form of electromagnetic waves. Okay, so this is a small comparison between frequencies. Okay, you also, if we talk about wireless, then we talk about satellite communication. Satellite communication, definitely a satellite is connected wirelessly. Okay, satellite communication is a communication system in Earth orbits that receive and transmit data at a very high speed. However, the development of high-speed fiber optic cable at relatively low cost. So fiber is lower in cost than using satellites. Okay, has reduced the need for satellites. Satellites can send data to satellites in orbits. Okay, so these are satellites in orbits. However, there was a question about satellite data. Advantage of transmitting data using satellite, not fixed to a single location. So a satellite may cover a country or a continent. Okay, allow access in remote rural areas where you don't have infrastructure. So if you're in the middle of the desert and you want connection, you may only connect using satellites because there is no infrastructure. Okay, disadvantage, high latency. There is a very big delay. High latency, lag. You can notice lag when, for example, you are watching a television and they say, we have our guest over satellite links. So there is a delay in the conversation, more expensive than wired, need extra equipment. The signal is affected by bad weather. If you have rains, you have clouds, these affect the communication speed with the satellite. Okay, the transmission speed is slow than fixed line broadband. So if you have a fixed line broadband, you would never use a satellite. You only use a satellite when you are in the middle of the desert with no infrastructure. Direct line of sight with the satellite is needed. Okay, so that was a question about satellites. I am deeply concerned with how that topic is being discussed in past paper. Okay, cell phone network. Also, cell phone network is wireless. However, with cell phone network, you need towers. You need towers for data transmission everywhere. Okay, cell phone has the capability of gaining internet access. You may get internet access out of your 4G connection. Okay, this is provided by the mobile companies acting as ISPs. ISP is internet service provider. The mobile phone communicates with a standard cell tower. This is a tower. And you have many towers because every tower is covering a region. For example, a circle with a radius of like maybe 5 kilometers or so. So you have several towers. And every tower is covering a cell. That's why we call it cell phone. Okay? Access the wireless telephone network, which then provide connection to the internet. Cell phone network can send and receive data to all towers over mobile connection. You have the flexibility of moving around with your cell phone, and then you are communicating with the nearest tower. Okay, another, again. My notes is so full of material from past paper, comparing cable and wireless transmission. So here we have advantage and disadvantage between cable or wired in general and wireless, that is radio signals in general. There are a number of points to make to it. Consider relative advantage and disadvantage. Advantages: devices can be mobile. If you are advantage of using wireless, devices can be mobile. Your cell phone, you can use it anywhere in the country. Also, your laptop, you can use it anywhere in the house covered by Wi-Fi. You don't need to be connected to the cable. Easier to set up, no cable. So you just put the wireless of the Wi-Fi. Easier to add additional device. Many different types can be connected at the same time. For example, at home, you may connect your laptop, you may connect your smartphone, you may connect your smart TV, or maybe, for example, if you have home automation, you may connect all devices wirelessly using Wi-Fi. Disadvantage: easier to hack, more interference, signal degrades quickly through walls. Okay, and these are questions. Let us look at this. This is the most useful part of our lesson. Description: wireless media, it uses radio waves. Twisted pair is an example. You have copper cable. Uses light waves, so it is fiber optic cables. Wi-Fi is radio waves. Fastest transmission media, this is fiber optic cables. Again, more questions. Fiber optic cable transmit light pulses and less likely to have interference. So here you are connecting to more than one option. Okay, so fiber optic is transmitted using light pulses, and it is less likely to have interference. This is fiber. Radio waves, large range of wavelengths, and it is wireless. Copper cable can be twisted pair or coaxial. Satellite, large range of wavelengths, and it is wireless. Okay, if you can successfully answer these questions, then the examiner will award you marks, all the marks, because you have an understanding of the topic being discussed. Now we move to another topic that I wish will be familiar for you. LAN hardware. You should know what a hub and a switch are. Okay, so a hub and switch both are used to connect data in a local area network. Both are used to connect computers in specifically in a star local area network. Star local area network. Okay? So, however, the hub transmits data to all computers in the star net topology and may cause collision. The switch only transmits data to the required computer and it will cause no collisions. So that thing we need to study about collision avoidance is already eliminated in the switch. However, it may occur if you have a bus topology, and it may occur if you have a star topology with a hub, because it broadcasts all data to all computers, causing collisions. However, the switch only transmits data packet to specific computers and causes no collision. So this is a star topology with a hub connected to all computers. This is a star topology with a hub connected to all computers, like this. This is a star topology. This could be a hub or a switch. Okay? The switch learns which devices are connected to which ports. The switch stores addresses of each computer in the network. Typically, it would be the MAC address. Okay? Of each computer, and directs data to specific computers or device. Each packet has address of the recipient, destination address. You should have studied about data packets in the O-level computer science, and maybe also in O-level ICT. Okay? The switch reads the address and identifies where the recipient is and transmits data packets directly to and only to the recipient. So the switch is much better than the hub. Why do we need to study the hub? For comparison. Maybe nowadays hubs are never used. Okay? First they invented the hub and it was broadcast. Then they invented the switch and it was much more expensive than the hub. And now the switch is not expensive at all. So everyone is using a switch. However, you still need to study a comparison between them. The bridge. The bridge is used to connect different parts of a LAN. So they function as a single LAN. So you have here a switch with computers connected to it. You have here another switch with other computers connected to it. And you'd like to connect the two switches together, you put a bridge. The bridge connects two different networks having the same protocol. Because this is a local area network, this is another local area network. They are Ethernet, and you just put a bridge to connect both together. The bridge is very simple. Okay, network interface card. In every computer, you need a network interface card. That network interface card will have a socket to connect the cable to. We are talking now about wired network with twisted pair cables. Okay, a network interface card is needed to allow a device to connect to a network. Okay, every network interface card will have its own MAC address. Okay, every network interface card will have its own unique MAC address. Okay, Network cables, we need cables. Twisted pair, for example. Even though many computers use Wi-Fi, network cables are still used because, so these are the advantages of faster data transmission over Wi-Fi. Cables are much faster than Wi-Fi, more secure than wireless network. So we are discussing here LAN hardware. Repeater, we need repeaters to boost the signal. The repeater is a device that connects two cables and provide a full strength signal to the second cable. So it boosts the signal. Okay? We also have Wi-Fi. So Wi-Fi is wireless technology. Okay? Here, what do we have here? Instead of having a switch at the center of a Wi-Fi network, we have a wireless access point. We have a wireless access point. And we also have wireless network interface card. Okay, so you have a wireless network. We call it WLAN, wireless local area network. Okay, so instead of a switch, we will use wireless access point, WAP. Instead of having network interface cards in the computer, we will have a wireless network interface card inside computers, or smartphones, or smart TVs, or any device. Also, any wireless network interface card will have its own unique MAC address. Okay? Okay, functions. These are all exam questions. Please study them very well. Functions of wireless network interface card. What is the function of that wireless network interface card? It converts data into radio waves. In the first place, it converts data from electrical signals into wireless radio signals, radio waves, to be transmitted wirelessly. Okay, let us read the mark scheme. So actually, as you can see, this is raw text from the mark scheme. Provide interface to a wireless network as an antenna. So inside that wireless network interface card, there is an antenna. Receives analog radio waves and convert them into digital. When receiving, it receives waves and convert them into digital. When transmitting, it convert digital into radio wave. Check incoming transmission for the correct MAC address. Because if data is having your address, you receive it. If the data has the address of some other device, you don't receive it. And ignore transmission not intended for it. Encrypts data, decrypts data, take single input and convert to analog waves, and sends the radio waves via the antenna. Okay? This is the opposite to this. Okay? Here, receive analog radio waves and convert them into digital. Here, takes digital input and converts it into analog wave. Here, while receiving, here, while transmitting. Okay, Shabab? So that was any question. That was a question. And your answer reveals your understanding of the topic. Then you collect all the marks. Okay, Shabab? Okay, next, what else? About networking hardware. We have a router. A router is typically used with larger networks. Let us say with wide area networks. Let us be more specific. Routers are used with the internet because the internet is a wide area network. The internet is a very large network. Okay? And the backbone or the fabric of the internet is a huge collection of interconnected routers. And this is the idea behind packet switching. Okay, let us study everything from this diagram. This diagram tells the whole story. For example, this computer is transmitting data to that computer. They are not directly connected. At all these intermediate stages, there are routers. In your city, in the neighboring city, in your country, in another country, until the data reaches the recipient. Automatically, every router has what is called a routing table. What I'm saying now is just in the ICT O level and is in the computer science O level. And thankfully, AS Computer Science is explaining everything from scratch. Okay, regarding this topic. Okay, so also programming, but however, programming goes rapidly into high and complex levels. Okay. Okay, so every router has its own routing table. Okay, and for example, the data is divided into packets. Every packet has its own destination IP address. So this router receives a packet, inspects its destination address, and then looks up in the routing table and decides how to forward it. Okay, for example, to this router, then to this router, to that, until it reaches that destination. Also, other packets in the same message, other packets in the same passage may take different routes. For example, this, that, and that, and that. Okay, okay. There are so many benefits and drawbacks of having packet switching. We will study this in the A2. However, we just look now at routers, and they have alternative routes. Maybe that green route is the shorter. Maybe that red route is longer. Why would the packet ever take a longer route? Because maybe there is a congestion in one of the links in the green path, or maybe one of the links is broken, so it takes an alternative path. Okay, okay, let us read the text now. This is my explanation. Let us read the text now. A router is a device that acts as a node on the internet. So the internet is just a very big mesh of networks, of routers. The router transfers data from one network to another. Here you have a network. Here you have a network. So every router represents a complete network underneath. Behind, there is a router, there is a network behind each router. So the internet is a network of networks. Okay, it is very intelligent. The router is the most intelligent device in the network, forwarding data packets to the destination by the most efficient route. The router receives packets and forward toward the destination using the IP address. Definitely a router will be using IP addresses. A switch will be using MAC addresses. Okay. The router operates between several similar network using the same protocol. However, all these networks are on the internet, they have the same protocol. The router at your home is called a gateway. It's not really a router. Sometimes we call it gateway router, or sometimes we just call it a gateway. A gateway is the router at your home because it connects two networks of two different protocols. The gateway router at your home is connecting your local area network with the internet. The local area network at your home has Ethernet protocol. The internet network has Internet Protocol. So they are two different networks of two different protocols. Then we put the gateway. The gateway is a device that connects networks of different underlying technologies or protocols. The gateway is used between two dissimilar networks. The gateway is required to convert data packets from one protocol to another. Because in the exam, they may ask you to distinguish between a router and a gateway. So here, the router connects networks of similar protocols. Okay? The gateway, see a comparison between a router and a gateway. Okay? That was in an exam. So please study carefully. Okay? Okay, so let us talk about the routing table. The routing table, the router has a routing table. The routing table has entry for associated network ID and host address. We will be studying more in details about addressing. We will study lots of details about networks in this chapter. This chapter is very, very useful. Okay, so the router, okay, in brief, the routing table is used to make decision on where to route packets. The routing table is used to provide data to make decisions about where to forward the packet. Okay, let us look at these exam questions. Receive packets from device. This is performed by a router. Finds the IP address of a URL. This is not performed by a router. This is the domain name server. Where you type www.amazon.com, this is the URL. And then it goes to the DNS, domain name server, and it will be converted into IP address. This is not the duty of the router. This is the duty of the DNS server. Why do we have it here? This is a question. Directs all packets to all devices attached to it. This is not performed by a router. This is performed by a hub. The hub broadcasts data to all devices connected to it. Store IP address and or MAC address of all devices attached to it. This is performed by the router. In my opinion, the router only deals with IP address. The router is not able to deal with MAC address. However, it is written here and it is acceptable. Okay? We will study lots of information about the IP address and the MAC address. Okay, we know that a gateway is the small router you have at your home. The router you have at your home is very, very cheap compared to very expensive routers used as the backbone of the internet. Okay, a gateway is a device that connects networks of different underlying technologies. Okay, the gateway is used between two dissimilar networks. The gateway is required to convert data packets from one protocol to another. Okay, and then there was a question in a compare between a router and a gateway. When the exam asks you to compare, the examiner is expecting you to put similarities and differences. When the exam says compare and contrast, you put differences and similarities. Okay? Both devices regulate network traffics and connect between networks. Both receive packets from a network and forward packets onto another network. So these are the similarities between a router and a gateway. However, a router connects two networks using the same protocol, while a gateway can connect two networks using different protocols. Okay? What is a protocol in the first place? A protocol provides a set of standards for communication of data that gives a known set of rules for transmitting and receiving data. Okay? So we will be studying about lots of protocols, especially in the A2. Protocols are rules that allow computers to communicate and understand each other. We have, for example, HTTP. This is a protocol. We have HTTPS. This is another protocol for secure communication. We have FTP, file transfer protocol, for downloading and uploading large files on the internet. We have SMTP and other protocols for sending and receiving emails. The internet is so full of thousands of protocols. Just for now, know what is meant by a protocol. What is a server? A device that provides services. Let us first give examples. We have a web server that hosts a website. We have a file server that stores files commonly shared among all users of the network. We may have DNS server that provide the IP address of the domain name. What other? We may have a print server to host a printer commonly shared by our computer. We have a proxy server. We have application server to run applications on the cloud. We have many, many, many servers. Okay? Okay, so a server is a device that provides services via a network. It is a device or software that provides a specific function for computers using a network. The most common example to handle printing, server to handle printing. Okay, server for file storage, server for delivery of web pages. We call this web server. Example, file server, print server, proxy server, web server. Proxy server is for security. Application server. Okay, because soon we will be talking about client server architecture. Soon we will be talking about client server architecture. Okay, okay, next. Internet service provider is a company that provides you with connection to the internet, definitely for a monthly subscription or a yearly subscription also. So the ISP is the company that provides you access to the internet. Modem, that was from old age, I think, because nowadays we have ADSL. We have a router now at home, not a modem, because in old days there is a bit of old technology here. This is the PSTN, public switching telephone network. These are landlines. And when you connect computers using the PSTN directly, you will need a modem, because that PSTN, public switched telephone network, these are telephone lines, landline telephone lines. They used to be analog. And the modem converts data between analog and digital and analog to be transmitted through the PSTN. However, nowadays we have the ADSL. DSL means digital subscriber line. So the line you coming to your home is digital now. You don't need a modem. Instead, you need the gateway router. Okay, but let us keep modem here because it may appear in a question. It still may appear in the question. And public switching telephone network. This is when you call somebody on the landline. When you dial the telephone number of the telephone, the network establishes a series of connection links until there is a link between you and the destination. We call this public switched telephone network. Okay, it may be used to support the internet. However, now they put routers and gateways above. Still, you receive internet to your home through the public switched telephone number, but in much different ways. For example, the line coming to your home may be fiber, and this is a brand new technology. Or maybe ADSL with digital signal sent together with the telephone signal. So internet-based system, voice over IP, yeah, this is the internet. For example, in a Zoom meeting, we are using voice over internet protocol because our voice is not now being transmitted using the PSTN. Our voice now is transmitted using IP. IP means internet protocol. The voice is converted into packets, and packets are routed between routers until it reaches the destination. Okay? Telephone calls can be made using conventional phones, using PSTN system, over a wired network, or using a computer. So telephone calls can now be done using a computer, equipped with speakers and microphone connected to the internet. And this is what is called voice over IP. Let us look at this comparison. Connection is only used wireless sound is being transmitted. This is internet-based system. Dedicated channel used between 2 points for the duration of the call. This is the conventional telephone using a PSTN. Because with PSTN, you are charged for the whole duration of the phone call, regardless you are talking or not talking. Connection maintained through the telephone call, again PSTN. Encoding schemes and compression technology used, this is only used in internet-based system. Data is compressed and encoded and maybe encrypted. Line remain active even during power outage, maybe when the telephone line is, maybe it's not down here anymore, because sometimes when electricity goes off, the telephone line is still on. Okay. What else? Let us go a little bit further and see where we can stop. I have lots of things to say. Okay. Let us see where we can stop. Okay, we can stop here before client-server architecture. I wish to explain it, but it needs a lot of time. Dedicated lines, sometimes you may have dedicated line connecting to servers, for example. Dedicated line or leased line servers provide connection that is only used for that business, not using the internet. Typically, you connect your business to the internet. Through the internet, you connect to another business. But sometimes you may ask for a dedicated line between your branch and the other branch. For example, 2 branches of the same company. It is permanent connection, not through the internet. Benefit, faster. ماشي. More consistent, improve security. Drawback, expensive to set up and maintain. Disruption, would have no alternatives because you're not connected through the internet. The internet can provide alternative routes through routers. However, if you are directly connected, for example, through PSTN between one branch to the other, if that one is broken, there are no alternatives. Okay, let us stop here and let us look at exam questions. Okay, let us go to page 68 of the classified. A company allows customers to stream music from its servers over the internet. The company's internet connection is currently provided using copper cables. Identify 2 pieces of hardware other than cables that enable the server to connect to the internet. Discuss the purpose of each. You may talk about the router. You may talk about the gateway. You may talk about the modem. You may also talk about NIC, network interface card. However, every device with its description. So if you say the router to connect devices, the server to transmit data between the server and the internet, to forward data towards its destination. If you talk about the gateway, to connect a server that uses a different protocol to the internet, to join two different types of network. Why would you ever need a modem to connect the server to the internet over a telephone line? Okay. Why do you need network interface card to enable the server to connect to the network? The server itself must have a network interface card inside. Okay. Next, the company wants to upgrade their internet connection to fiber rather than copper. Here is said copper cables. They would like to upgrade to fiber. What are the benefits? Well, here they want one benefit, but the mark scheme will give you all possible benefits of having fiber and all possible drawbacks of having fiber compared to copper. So, benefit, faster transmission, more stable connection. Drawback, high initial cost, new hardware will be needed, expertise required to complete connection. Okay, Shabab? So that was a question. Okay, let us look at that comparison. So you need to describe fiber optic. Here, communication device in Earth orbit that receive and transmit. What is that device? Or what is that type of connection? You have your radio waves. So describe that connection. Carries data as electrical signal and can consist of twisted pair. What is that connection? Okay, somebody owns a small company with 4 employees. The office has a network containing several computers that run on a client-server model. We will be studying the client-server model in the next session, inshallah. Because there is a question here about client-server model, we will not be able to answer. This is the client-server architecture, where there is a server in the middle and all computers benefit from that server. The opposite to this is peer-to-peer model. So without a server in the middle and computers are sharing resources with each other. Next, inshallah. This is going to be on next session, inshallah. Okay, so I will not be answering that part today. There are one server that connects to the internet using a router. Network transmitting data using various types of connection is shown in the table. Complete the table. The type of connection. Fiber optic, describe fiber optic. Transmits data as light. Uses a bundle of glass or plastic threads to transmit data. This is the best description of fiber. Okay? A communication device in Earth's orbit that receives and transmits data, you put satellite. Radio waves, for example, used with Wi-Fi. Carries data wirelessly, often known as Wi-Fi, carries data in the form of electromagnetic waves. Okay? The last thing, carries data as electrical signal and consists of a twisted pair. This is copper. Okay, Shabab? We will not be doing this. Also, we cannot do, as you can see, questions come together. Still, I didn't teach you about public IP address. Maybe you know it from the O-level computer science, but I will teach it. Okay, please, please, you go and solve all these. Okay? Okay. Okay. I wish you luck with your study. Inshallah, please work as hard as possible.